Hi, this is Ayush, and I'm from ClimatePub4KG team, and this is Climate Publications Knowledge Graph, a technical masterclass. So I'll be going over the technical details about how this graph was created. So before that, a slight motivation about how the ontology was created. So we've already, over the past year, worked on a knowledge graph, a climate knowledge graph, and previously we worked with the concepts from GCMD plus. Now, GCMD is a global change master directory, so it's a NASA's uh, ontology that they created, and GCMD plus is something we added to that to add to or expand that ontology. And initially we started from that, but what we found out was about metadata from ESGF, which had a plethora of information about climate knowledge graphs, specifically about climate models, about experiments, variables. So all of this was pretty well documented and in a standard form in ESGF. So um, initially we started with these climate concepts, then we also added concepts from CMIP6 CVs, which is concepts regarding genealogy, which climate model components are present for a specific climate model present in ESGF. So these were really important to trace out the genealogy concepts of climate models. Then we also have an information extraction pipeline, which we'll be talking about later, but based on that, we made minor modifications. We are learning along the way as to what kind of information that is present in scientific publications. So previously we had climate zones, but this um, we quickly found out that usually information we usually had geographical zones, and we found out that geographical zones like Indian Ocean are usually present with a climate zone, say tropical Indian Ocean in climate publications. So we also added climate zones to kind of refine that. So we are refining along the way. We are refining our ontology along the way, but yeah, so those are the things we are doing. Also, what we did was we also included natural hazard type, which is another type to integrate with other databases. So NOAA's event database, they have a storm knowledge graph as well. So to integrate with that, we also added a new concept called natural hazard type. So this is for a potential merge. So how was our knowledge graph constructed? So our knowledge graph, the basis, the foundations of our knowledge graph, it's based upon the ESGF, which is Earth System Grid Federation dataset. So ESGF has a lot of climate datasets, either simulated or predictive. This ESGF data, what they have is they also have metadata information about each of the dataset. So for example, dataset D1, you can see in a tabular form, they have which experiments this data set is produced from, what is the source ID. Source ID means climate models, global climate models, which variables are produced in this data set, which for which region or which bounding box does this experiment cover, and all of these informations. So based on that, what we do is using this tabular data, we create entities, and from our ontology, we map these potential entity instances to with the relations from our ontology. Now, what do we do with the bounding box? So we use that bounding box to connect it to actual geographical locations. So for example, the bounding box that you see here, it covers Toronto and also North Atlantic Ocean. So we usually uh, connect the instances that we had there with also the actual geographical entities. So after ESGF, we also map our climate models present in ESGF to CMIP6 CV. So what they do is they also capture climate model components. So climate model components, they're not present in ESGF as such. They're only climate models that are present. So why this is important is we can also track down genealogy concepts. So say example, two access models, they use the same oceanic component. So how do we know that? Using this knowledge graph, we can just query both of those access components and kind of find out whether we have overlapping climate model components or not. So CMU6CV, it provides us that information. Um, Now, with regards to geolocation data, we kind of saw how we linked bounding blocks to geolocations. So for that, we have regional climate models. They predict over a certain region, and this certain region is mapped to geolocation entities. So we use the either the point, longitude, or latitude information, or the overlapping between bounding blocks information to see where the regional climate models cover certain regions, right? So regional climate models also have certain domains, and these domain information is also used to map uh, climate model region with a climate model domain with actual geographical entities. So, what are the delivery mechanisms of this? So we saw how the knowledge graph was constructed, and based on how the ESGF data, we also kind of saw that we connected the climate models with their components from Simu6CV. Then we kind of saw how we connected geographical components with actual regional climate models. Now, all of the visualizations that you saw so far, they are based on Neo4j. So they are Neo4j databases. Our primary method of delivery is Neo4j. We've worked on this. We already have a hosted interface for Neo4j. And in this hosted interface, we will do the primary work. Uh, we know that Frink, it's a federated database, and we also convert our Neo4j database. So because Neo4j is the primary delivery mechanism, we also convert Neo4j. We have a tool to convert Neo4j data to triples of and triples which are compatible with Frink. So all of this data is also available in RDF and Frink platform. And finally, our primary source is a primary delivery mechanism is Neo4j. So we also have a chatbot interface for those who are not familiar with Cypher and those who just want a more convenient interface. We have a KG chatbot interface where you can just enter natural language queries, and through that natural language queries, it will perform a translation to Cypher and provide you a visualization along with a natural language answer. So say you have the query, so regional climate models that predict precipitation over Florida, USA. How would you perform this query, right? How would you perform this query? So Neo4j query, so for those of you who are familiar with Cypher, this is a pretty standard Neo4j query. So you can look at the properties, you can look at the basically the entity labels. So RCM is a regional climate model, source is a global climate model, and you can basically look at the ontology and see which entity labels are connected with what, and through that you can find relation names. But this is a standard Neo4j query, which is, in my opinion, more human readable for some. This is a standard query to kind of get regional climate models. Uh, and what would the visualization look like? This is the visualization, which is what I like about Neo4j. So it makes it pretty clear about which regional climate models are connected to which global climate models, which variables are related, and which geolocation entity we are connected with. So this is a pretty standard visualization. It helps to expand more on certain things. So say if you wanted to look more for about Remo 2015, say you wanted to know more about that climate model, you can simply basically expand on that and know more about it. So there's an expandable visualization interface in Neo4j browser. So this is one of the preferred ways, specifically for people who know about Cypher. This is the preferred delivery mechanism. But obviously, we also have a Sparkle compatible interface in Frink deployed on Frink. So you can essentially perform queries similar to this. This query is actually longer than it should be because we didn't add the prefix. We wrote the prefix as a whole. But yeah, so this is also something you can do. You can query you can provide the Sparkle query in the Flink interface and obviously get the required results as well in a more in a form which is more familiar with most of the people doing knowledge graphs. The Sparkle query is more popular than Neo4j, I guess. And there's also chatbot, which is a very convenient way of basically uh, deploying our model. So if you have any natural language queries, you just say, show me regional climate models that predict precipitation over Florida, and it kind of gives you a really compact, clear answer. And so this is all of it is provided by the knowledge graph. And if you want to dive deeper, there's also an open Neo4j link below. You see in the and you can just it will just simply redirect you to that visualization interface if you want to do more on this. So this chatbot is something we are working on, and specifically we are working on adding more. We are working on adding climate publications, and that will obviously change our graph a little bit. We'll work on the climate publications, and they'll also be queryable through chatbot. We're also trying to improve the natural language query interface, natural language to cipher translation interface. So in conclusion, we created a domain-specific knowledge graph that captures complex relationships in climate science. We enabled structured semantic queries that support scientific discovery beyond keyword search. And we also demonstrated an integration with RAG systems to improve LLM reliability for climate science. So this is it. Thank you. If you want to reach out, you can email me at ayush.acharya@temple.edu and we can talk more about this project. Thank you so much.